can learn a lot.
Recording is on.
The very great arts here using. Also, they started the NFT collection also at OpenSea. But yes, I use this software, this website here for a long time. I have, and now is amazing. You can create your sketches, your programs here, and save it online. And this is the first. I will start to explain what is P5JS. P5JS is this processing ported to JavaScript. Okay, JavaScript is a programming language more focused on internet, on browser. You can run all your applications on the browser, and processing is very powerful. You can do a lot of cool things with processing. This website, official website, also you can learn everything because in the reference is all the functions, the basic functions from this is a kind of a JavaScript library. So P5JS, this reference link inside the P5JS, you can you all the functions, the basic native functions from P5JS is here. You can learn from here. Also, you can see the math functions here. So yes, you can make simulations like Leo was talking about the use it a lot in biology. You can run simulations. You can input the math formulas and in code, transform the math formulas in code, and it's really cool. So yes, have these basic math forms here. You can use. Nice. This just showing the website, and P5JS is a part from processing. Processing.org. This is the official site of processing. So the beginning, the father of P5JS is processing, and have the processing foundation. Processing, yes. Processing is three things: the community, the website, no, the website, no, the program, the software, processing software, and also programming language. So, and you can download, it's free. It's 2001. The last class you can is shared on the Metaverse DAO forum there in the near forum. I have the last class. I explain a little bit, just talked about the year and this processing history. But yes, it's 21 years now from the beginning. So, okay, we will use the P5JS. In the last class, we made this little animation using only noise, random, and rotations. We will use this again, but now I wanted to show how to use the sine functions, sine and cosine. And I will explain the basics for you are the first, was not in first day today, and we will go from the beginning. Now, like the last time, I just want to explain the basic. When you are in this website, you just click here to create a new sketch. All the processing programs you write, they call sketches. And when you open a new sketch here at Open Processing, you can see this animation. Like, is an interactive animation here, painting balls at the mouse position. Okay? It's simple program to paint in the draw in the screen balls at the mouse position. Okay? This is the program. When you open this, and you have these two blocks of code. The first block of code is this setup function. It's the native function of processing just to configure the to start the program, the basic configurations to the program. So here we have just two lines here. The first line is create canvas. This create canvas function is to define the size of the screen of your program, the canvas of the program. So, and inside, receive two numbers. You can put here two numbers, like if I put 400, 400. It's 400 pixels by 400 pixels. The size of the screen, okay? And now in the second line is two numbers. The first is width. Numbers, width and height of the canvas. And the second line is the color of background. Like the colors. This way you can input only one number, is grayscale. If you input 0, is background black. If you input 255, is white. So 0 to white. You see. Gray. Okay. And then we have the draw function. The draw function is where the animation lives, or the program, the logic of the program, the things who need to be executed 60 times per second. This circle is executed 60 times per second in the screen. If I'm here, he is drawing ellipses 60 times per second in the screen. If I go very slow, see, is a lot of ellipses, lots of circles being painted. If I go fast, less, like 60 per second. Okay. And inside circle, the name of the function, you know what is doing. Circle is drawing a circle on the screen. And the circle function is only three numbers. The first number is position at x-axis. And the second number is position at y-axis. The last number is 20, the diameter of the circle. I can input 200 here, and a big circle. 200 pixels, the software is 400, remember? Okay, But here, okay, let's leave the other way. Window widget. Window 8. This defines the size of your screen. Will be the size of your browser screen, like the canvas of the browser. If I see the size of the canvas change accordingly to the size of the browser. If I now always the full screen, like if I refresh, when I refresh, okay, really simple. Here, the setup, the only thing, the setup is these two lines, this line is inside of these brackets, is executed only one time when you press play, and then is 60 times per second the code inside these other brackets of the draw. Okay? Okay. So yes, like the last time we saw the random and noise. Today I will explain to you a little bit about sine functions, sine and cosine, the math functions, trigonometric functions. So let's put this ball. Stop this ball. It's not moving. It will be in the center of the screen. Read it. Processing the position at when we are using the 2D mode this way. So the top left is the 0, 0. If I put 0, 0, let's put 0, 0 before. The cool thing about processing, you can change the code and you can do whatever you want, and you will learn by doing. You can just browse inside open processing, check it out code, and change the code to see the results. But I will save. See, now the ball is at 0, 0. I can also do this. The 0, 0. See, top left. Okay, this is 0, 0. If we want width, this is the width, returns the canvas width. Okay, it's like this number. Width is a function return this number, window width. Split by 2. Center of the screen at the x-axis. Height by 2. Center of the screen at the y-axis. If 0, 0, if you increment the y-axis, you go to the bottom of the screen. If you increment the x-axis, you go to right. Okay. So it's very cool. Sine. What is sine? Sine and cosine. Remember, high school. Somebody can help me now? Maybe. Somebody knows what means sine? Can give me a light? Maybe. I'm from social science, humanities. Somebody want to try? Yes, please. Sine. What is sine? Too many years. Remember, you think, I never will use sine again. Why I'm doing this? I will never use this. I will not learn this. Nobody want to try? Nobody want to try? A little bit? No? Okay. If we don't know, like my friends from Antimatter Down, they say, if you don't know, just Google it. I will show you a few images about this. Okay, what is sine, sine and cosine? Sine, like, most important thing is this. Let me give a zoom here. Sine and cosine functions are commonly used to model periodic phenomena such as sound and light waves, the position and velocity of harmonic oscillators, sunlight intensity, and day length. Okay? Periodic things. Okay, sine is from the word also the sign, like the bell, the form of the bell. But yes, periodic phenomena, okay? And also, wherever when you go to study sine, you saw these drawings, okay? This sine and cosine, okay? This sine wave, sinusoidal wave, okay? This is the graph. The sine is the red wave, cosine is the blue. You see, sine and cosine are almost the same, but you have the, how can I say, the offset, like a little offset between sine and cosine. But they do the same thing. They go from 0 to 1 to 0 to -1, and then goes back to 0 and forever and ever this way. Okay? Like this is the sine wave. The math formula is go from 0 to 1, from 0 to -1 to 0. Okay. And this is angles also. Have this other image here. Like when see this, when the wave is on top, have the 0x, 1x, -1x, 1y, 0, -1. Okay? Just these possibilities. Okay, of course, have the infinite numbers of angles in between these numbers. Like, it's decimal numbers. It's from 0 to 1. It's like float. You know, float is like decimal numbers. You go from 0.000, like pi. And also use the pi here. You see, we are using the pi here to 0, 1 pi, -1 pi. Is the, okay. Just to remember, give some headaches. Okay? These graphics. Let's code this. Okay, why is the use of sine in any animation when you need some periodic repetitions? Like if you want something growing and going up and down, up and down, up and down, you can use a sine function to this very easily and have this movement. Like, let's make something very simple. Like in this circle, let's use the sine function to move the size of the circle, okay? But just to finish, I starting to show and try to explain. It's hard, but think this is 0, okay? 0, and you go to, it's like, you know, where is the like, how I say, like you use this pi, and you to use pi to count angles. Use pi, like 2 pi is like 360, and half pi, 1 pi is 180 degrees. 0 pi, let's say 0 pi, see the circle here? 0 pi can start here. If you want to move the clock clockwise, going down here and increment. 0, half pi is like 90 degrees, is half pi. Okay, you remember this. High school, half pi, 90 degrees, basic. 1 pi, 180 degrees. And 360 degrees is the full circle, is 2 pi. Okay? Easy. This basic high school math. Basic high school math. So how it works? Sine and cosine, they receive an angle. If I receive, like for example, if I receive 0, I will be like here, but of course you have the radius also. But the thing I want to show you is sine function receives an angle, and depends of the angle will return a number between 1 and -1. It's basic. Depends of the angle. Each angle, you input an angle inside the function, returns a number between 1 and -1. Okay, this is how the function works. Like, for example, I don't know how sine function works, but I want to know. Like I click here, math, sine, let's see, sine, where is the sine function? Oh, now, trigonometry, sorry. Math functions and also trigonometric functions. Lot of this, see this. Lots of trigonometric functions with processing, but let's see the sine function. Sine function, let's see the description. Calculate the sine of a angle. Return in the range of -1 to 1. You input an angle and return a number in the range of -1 to 1. Okay? Not so good, but is this? It's right down here. Okay? It's the basic description, is the documentation of the reference of P5.js. Okay, let's do it. So let's say you increment the angle. When you increment this little angle, you have this periodic movement. Okay? Okay. So it's just like this. Plus sine an angle. Like 2 pi. Let's say 2 pi. 2 pi. 2 pi. 2 pi, you know, is 360 degrees. And I will can just put a number here, like if I want 1 degree, 360. But I want this incrementing. I will use another function I teach last time. Is a function for a timer, like count how many milliseconds my program is running. The return is like a clock. Another function in processing is a clock. But like if I put this number, nothing will happen, because stop it. But I can multiply the amplitude, like is -1 to 1. So the amplitude, I'm summing a number in between -1 and 1. If I want to change the position, I need to multiply this for a number to amplify this movement. Like I will say 50 pixels. Let's see what happens. Move a little bit, but nothing happens. It's not moving. We want some movement. So we need to increment like this number. This number is very little, 2 pi. What is this number, 2 pi? Let's say, I can write down on the screen, 2 pi later. No, let's do. Sorry. Use, to make this movement, the best way is to use millis function. If I do this, see, yes, we got the movement. It's a little bit fast. And we have a problem. The background is not being painted. It's being painted just one time because it's active setup. So we see all the circles. But here, what is happening? Is going to 250 pixels wide to 150, because it's when is 1 multiplied by 50 is 50. Minus 1 multiplied by 50 is minus 50. So I'm adding and subtracting 50 pixels to the size of the ellipse, the circle. But okay, let's see this better. If we input the background inside the draw, we will paint the background every time. So it's not having the trail again. But you see, it's very fast. That's because the millis is returning a very, very big number. Millis is going from, in 1 second, he is counting from 0 to 1,000. So you need to make this millis number. You understand? It's millis. Count. Let's see the reference. Show you here the reference for millis. It's returning the time in milliseconds our program is running. The time, how much time? Okay, millis. So it's coming from 0 to 100, 1,000 in 1 second. So it's a very big number. We need to make this number a little bit little number, not so big. Make it little. So we multiply by a very little number. Let's say I multiply millis per 0.00008. Now is not so big. A little bit slow now. Too slow. That's too much. Let's see. Now we got it. See? This is a sine movement. Okay? We are having the movement. Pulsing. Nice? Okay, let's try to understand this number. But you understand what happened? What's happening is adding and subtracting 50. The sign, this is we are adding the angle for very, very little steps. Adding the angle for very, very little steps. If we make this little, this number more decimal, you can see is more slow. And if this number is bigger, faster. But periodic, and is being running with this function called millis. This is a very simple way to use it. Of course, I didn't create nothing, no variables, nothing. Just one line of code to make this. Okay? Right. Let me see your faces. Nobody have faces now, but there is. Tell me something, please. Easy or not so easy? Let's make it slow. Okay, now, but I was talking about this is only a simple way to use and make something periodic. Little, you can make a heart, you can make this animation in, animate some PNGs with this. You can do a lot. But I was talking about the circular movement. Okay, the circular movement, we need to input not in the size of the circle, but in the position. And like I told you before, when you know we input an angle inside sine and cosine, we return a position in the tangent of the circle. You can do the put on top of a circle. Like let me do just a little bit another thing. Like now I will put a no fill. I will take the color fill inside the circle. And this I will put leave. Took this. Now I have one. I put 300 here, okay? For 300, okay, is so we see this stroke of the other circle here, okay? Now I will show you, make the movement only at inside the circle, make the circular movement around the circle, okay? So let's do it. Have a little math form for you to do it. Let's do it. Now we'll use this again, fill. Will be a little circle. Now I will make it another color, like green. If you input 3 numbers, you can use the RGB system. If you input 4 numbers, you have the opacity, the less. This RGB. Now I will put another circle. I will put in the center of the screen to begin. But then I will use sine and cosine to position on the circle. Just a little ellipse in the center. Let's see. Oops, I forgot to close this parenthesis. So I have this in the center. Now, let's use sine and cosine to position this circle. And have a little formula for do this. The radius of this big circle. We need the radius of this big circle. What is the radius of the big circle? It's half of 300. 300 is the diameter. It's like this size of the 2 times the radius. So 150 is the radius. Multiply by sine of an angle, 0. Let's make it, don't need to make movement now, but in this the same formula, but cosine. Let's see what happens. Oh, yes, work it. See what I did? Exactly at the point I told you. Not exactly, but we can change here to see what happened. Cos, work it, 0, angle. Now we can use this same function to run the angle. Like I just incrementing the angle for a very little number. Now it's not 0 only, it's just incrementing the angle. Beside the cos and sine, I put the same formula. Control C, Control V. Let's see. Cool. That's so cool. Red. Magic. One line. Something. Tell me something, please. Hard. Very hard to understand. This for two formulas. This is the formula you need to understand. I will, just for sake of, can see better these two formula. Like the position center of the screen, width plus radius multiplied by cos of an angle. If I input each angle, like let's put pi here, we'll stop in 0. We know what's here. If it's pi, we'll stop here. But cosine and sine is this for you detect the exact coordinate in a circle. Now, this is amazing. You can do a lot. We can mix this with noise, random. But this is the basics. This is the basics. One of the most easiest way to use the sine and cosine. In the first, let's review, okay? This just running an angle. This is sine, receive an angle, is incremented by a very, very little number. In fact, you don't need the 2 pi here. You just need a little number. Works the same way. Okay? I put the angle there because we are talking about sine and cosine, so it's angles. You can use angle is a good way to start to work with sine and cosine is using angles in this way. Then like 2 pi, if you wanna, like I told you, let me just, I will, let's see, we can just comment this line. Comment, I will show it. Was really hard to understand the sine and cosine this way? Tell me. Not so much, a little bit. What you think? What you feel? Like I was told to understand. I have another code, but don't need to show you. Just I will show you. We'll copy this line. These two lines. Copy these two lines. The green circle is running around the circle. Now I will put a red circle. And we will input the number of the angle, like pi. Here is not will be moving, but only pi. Where to show if we input the same angle, pi and pi, see what happened. Stop it there, pi, like half pi. Pi divided by 2. Okay? Pi divided by 2. Okay? If we put pi multiply by 1.5 pi. And multiply by a number. 2 pi multiplied by 2 is 2 pi. 1.5, 1.5 pi. Right? Now, it's cool, but it's not so beautiful. We can make something beautiful. Would be nice to make something beautiful. What? How? Using noise like we have. Let's use noise now. Because we have this 150 is the radius of this 300. That's this only the stroke of the circle. This black stroke circle. So we can apply a noise here. The same way we use noise returns a number in between 0 and 1. So it's the same logic. We use almost the same functions. Noise, millis for run the noise. Noise, you need just to increment a number inside noise to have this noise movement, the organic movement, not so randomic and chaotic movement. It's more organic movement you can have with noise. So millis, and we need to multiply this millis like the other time for a little number, for we have a more soft movement. We multiply for a little number inside the noise. Inside the noise, okay? 0.wait, this bracket was wrong. 0.008, like I put the last time, and close the noise. And now we need this amplitude of this noisy movement also. We can multiply again by a number like 50 pixels. And then, okay, we need to do the same thing to the XY axis and to the Y axis. We have the Y axis here. The same thing. Almost the same. We can put some number inside for don't have a little bit offset in the X and Y axis where don't have a diagonal movement like we saw. We can put like a big number just to begin. And see what happens. Oh, something wrong. Month code. He's missing a parenthesis. Look, line 16. Missing a parenthesis. Here. Forgot. Need to close the noise. Because something. Opa. Close the noise. Close the noise, and I will put this parenthesis here just to make this part of the code. Let's see. No. The default where my mistake with plus a little bit big function. this, wait, cos, why? After argument list, some noise, millis, too much. Something's not right. Something's not right. Oh, that's not what I want. Forgot it. Wait, I will do it again. It's almost the same of the Control Z. Let's do it again. Something fail here. Now it's time to start to use variables, because C is the code. You need to make the code a little bit more readable, and I'm inputting everything a little long, very long line here, and we can make it more easy to read if we use some variables. Like, let's say I will create one. You know what is a variable? A variable in code, programming language. Like when you are writing a new program, writing some application, you need to store some values inside the computer. Like you need to store some values, change these values. Like, for example, we need the radius, circle radius. Okay? Let's make it easy and write down circle R. Okay? Now, I will make the formula here to change the circle radius with the noise function. Let's do it. So I create this memory space. This I create now. When I write this let circle R, I created a space in the memory to store some value. So circle R equals 150 plus noise. Now inside noise, need to increment a number using millis because it's the easiest way. But you can use another variable to write down, make other variables, just increment a variable inside the noise. But I'm using millis because it's a very easy way to have this increment in one line of code. I'd save one line of code with this. Plus 0.0008. Remember, it's a big number, millis. You need to make it not so big. You need to make it a decimal number. Close. And now, you need to multiply to make the amplitude of this movement. So, try 50. This way, now I just input this here. And the 150 is the radius for the movement, not the radius of the radius for the movement is this number, okay? make this green ball be on top of this big circle. Let's see. Now see, it's moving not so, a little bit, 50 pixels, not perfect. It's making a organic movement around we can make, see, faster, you're not so organic this way. I make it faster. Make it slower, it's more organic. 50, we can 150, see what happens. It's circular but have a noise. We are a little bit on time. We have 10 minutes more. I think I will stop a little bit here. Save it. Share the code. Somebody have some questions, doubts? We started to play with this, but we have a lot of more to do. We can do to make it beautiful. We can just maybe put this back. No, to make it beautiful, we need a little bit of more time and thinking. What you think about, people? You like it? Liked it? Was really hard? What think? Clara? Let me see what to talk. It's 44. Oh, sorry. Let me see the questions you talk. It hurts a little bit, but yeah, the first time is normal. But CV, OpenCV, don't know, Python, sometimes OpenCV, we have a lot of libraries for Gemini Rising is asking about CV, computer vision. Yes, we have computer vision here. Let me show you a little bit. Let me see. CV CryptoVoxel. Oh, okay, CryptoVoxels. No, not so much CryptoVoxel. Yeah, JavaScript, yes. But yes, I saw CryptoVoxel, you can program some interactions with Magica Voxel, and you can program in the space like with JavaScript. This kind of code, very similar. Probably this noise functions is the same with JavaScript. Noise and sign functions is, I think, we maybe really can be close to what we are playing here. Clara, a little bit lost. Let's see these questions here. Could we use a random to create this variating circle? Yes, we can. Here, I use the noise function for the variating circle. Now, not variating circle, you can also just displace, like if I want a random in between minus 50 and 50, we can just, you can use the random like one way to use it, very fun, is random to pi inside the sign. For example, not so random to pi. What? Que aconteceu? Missing argument 11. Okay, just missing one. And for this, oh, no. Yes. You see, it's just 50. 2 pi is a very little number. No. 2 pi. I will need to input like in this, inside this red circle. Let me, inside the red circle, maybe it's better. See if I, inside the red circle for you can understand this random to pi here, but for the sign also we need to input here the same random to pi. And now, oh, not so good. Why? But yes, you got it. Not so cool, but little bit randomic. Also, I think it's strange because they need to stay inside this black line. But we can do more. Let me see other questions. You got it. Yes, random is easy. Let me see other questions. Yes, the way to go is this. Change the code, experiment, but we have this simple examples like this pulse circle. Comment here for you can understand later. This pulse circle. This is the bigger circle, and this is the green circle. Little bit was fast. It's okay. It's 1 hour for. I will share again. Sorry, I changed a little bit the code here. Now this part of the code, let me do it again, just for you can see again. Just you can see the code before was this way, the white ball. Okay. Now, if we want to change the color, we can use the color, another color mode, the color mode HSB, hue, saturation, and bright. The 3 numbers inside is hue, saturation, and brightness. So I put 255, 255. And the hue number is the color. Is the color. So I will start at 125 plus sign, okay, the velocity, and multiply by 125 because we'll go to plus 125 and minus 125. 25. This way, we'll pass through all the colors. Little bit fast. If we can make this bigger. This way. Right? Can change the color with sign. For example, if we can make it not so less colors to change, this number can be not so big, and we pass through less colors, starting from 125 plus adding 55. That's it, people. Thank you very much.
That was awesome.
Thank you a lot, Metaverse DAO, Near Creatives. Hope to be with you again in another opportunity. I was talking with Beetlejuice. I wanted to play in your party sometime with my music project, with Dr. Crazy or Zydron, more electronic or rock. Yesterday I released my NFT. It was a music NFT. It was really nice. So thank you very much. Now we have the Todd class. Really excited to see also. Very nice to see everybody here. El Kush. Nice to see you, El Kush. Jamie Rising, thank you. Beetlejuice, Te, Diego. Very nice. Let me stop the screen. If everybody have some doubts, want to make contact with me, I will put my contacts here too. Okay? My email here. If somebody wants to send me a message or follow me on Twitter. Thank you very much.